So here's a great question that I want you to look at in terms of solving an inequality. I'm going to give you two inequalities that I want you to work with. The emergency flare malfunctioned and was propelled into the sky. Its original path was supposed to be this. So if you think about it, that's its original path. So if you look at this, its original path has to be up here, and it's supposed to go like this. But since it's malfunctioned, it can be anywhere below this path. So in other words, I can make this less than or equal to. It could follow this path, or it could just go boom and not make it at all. It could have just fallen in here, fallen in there, could have been anywhere in that section. Now, take a look at this. A telescope was placed right here. A telescope was placed at the spot at which the flare was propelled. So there's my telescope right here looking at this flare. And this guy, unfortunately, because of a set of trees, only has a line of sight that is going to be like that. Okay, so we got to solve this thing. We got to make this into an h equals 2 kind of thing. So let's just bring this over. This is minus 10h equals to minus 8t minus 15. Divide everything by minus 10. Divide it all by minus 10. You're going to get an h equals to positive 0.8d. Looks like plus 1.5. There we go. Excellent. Okay, so write the two inequalities. Well, guess what? This guy, since it's blocked by a bunch of trees down here, won't see this section. It'll only see this section up here. So we're looking for this double shaded region. Can this guy actually see, and for how long will this telescope actually see potentially this rocket that malfunctioned? Well, it'll only see it from this point to this point. It won't see it below it. Why? Because this has got to be greater than or equal to in terms of height. Okay, so draw a graph illustrating the event. We just did. Between what times of the height will the flare be seen? So we're looking for this time here and this time here. That's what we're looking for. So you know what I would do in this situation? I'd throw it onto my calculator and figure out those two intersection points. Calculator looks like that. Oh, there's the equations all in there, ready to go. Let's hit graph. Boom. Oh man, it doesn't show the entire path of the flare. So let's zoom out and let's see what we can find. So obviously my window has to be changed. My X values, oh, I don't know. Let's put it for 50 seconds. Let's see what happens. And then let's put our Y max. I don't know. Let's put it up to 100. Let's see what happens with that. Graph away. So I got a guy going like that. There's the flare, and oh, lo and behold, wow, great guessing on that one. All right, so let's find these 2 points from here to here, and that arc right there, because remember, this is shading up, right? This one is shading down. That's the flight. Could be underneath this parabola. This telescope can only see above this line. So the thing's got to be somewhere in here. Let's figure out at what point, this point to this point, let's figure out the times at which you can actually see this flare. So second calc, here we go. Let's find the intersect, which is 5. Mouse it down here. Woohoo! All the way down there. And we're close. Great. Enter, enter, enter. And I find at 0.338 seconds. So at 0.38 seconds, and then second calc, let's find the intersect, let's find the other one, way over here now. Come on, there it goes. Nope, doesn't want to do it now. There it goes. Okay, here we go. Almost there, and there. Enter, 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 and we find out that that's at 41.3 seconds. So between these two times, 0.38 seconds and 41.3 seconds, that's where you're actually going to see the flare. So the answer would be between 0.38 seconds and 41.3 seconds. Your value of time has to be between those two in order for you to see the flare. Otherwise, if it's before that time Or after that time, you got these trees up here that are blocking your view and you can't see anything, right? So the rocket could have landed in there and you have no clue where it is. So it's between those two times. You use this kind of idea, same kind of idea, especially when guys like rocket launchers for NASA and stuff would use equations like this to be able to determine when they can see the rocket as it orbits the Earth or not. Kind of a cool question.